All right. Unit 1 midterm coming up, polynomial test. Let's review for it. First question I have for you here. The graph of the function models the percentage of charge C in a phone battery over a period of time T. So this is the amount of charge a battery has. Okay, that makes sense. What we're doing, we have a charge of the battery. Based on the graph, how many extrema does the graph of function C have? So I'm going to pause on its domain. I want to have a few words here. What does extrema mean? Maximums and minimums. Maximums or minimums, that's great. And when it says on its domain, what does that mean? Okay, I hear x-axis. It specifically means all the relevant x values. Okay, so what am I saying? If t represents time, do we have negative time? No, so we're not going to look at negative x values. The starting time would be 0. This would be like time 0 right there. And this would be whatever time that is. So we're looking in between there. How many extrema does this graph have? Okay, so let's talk about an extrema, a maximum or a minimum. Do you see any maximums on this graph? I do. I see a maximum. Where's the maximum? At the very original. Is that a maximum amount of battery? That point would represent a maximum. Do we have a minimum? Yeah, right here. Now, what about in the middle? Do we have any maximums or minimums in the middle? So by definition, a maximum means the graph was increasing and now it's decreasing, unless it's an endpoint. These are endpoints. So endpoints always create either a maximum or a minimum. So a maximum is created when the function is increasing and then turns and starts to decrease. Does this graph ever increase and then start to decrease? Like, does the battery start to increase back in life and then decrease? No, so we don't have any other maximums in here. Okay, a minimum occurs when you're decreasing and then you begin to increase. So that would create a minimum if you're decreasing and then begin to increase. Does that ever happen? Are we decreasing and then start to increase and then decrease again? No. So there's no other maximums and minimums on this graph. Okay, so what you would need to do on the test, just so you know, is first off, how many extrema are there? How many extrema? We have 2 extrema. You would say 2 extrema, and here's how you would write this out. You ready? You would say there's 2 extrema. It switched colors on me. 2 extrema. And then you would list the values. This function is called C. So the way you would do this, let's just give it, what do you think the charge is? Just take a guess. What do you think the charge is when it's all the way at the top? What, you want to say 100? You want to call that 100? And that's time 0. So I know that point. Let's say that's a time 0 at 100. And let's just estimate. I know it doesn't say anything down here. We'll just say time is t. We don't, no, that's the tx. Never mind. How about, let's just make up a point. How long do y'all want to say the battery lasts? How many hours would your cell phone last? 5 hours. So we'll do 5 comma, what's the battery life there? 0. Okay, so here's how you would write that. If you remember, this one's called C, not F. So this is like y equals C of x, if that makes sense. The way you would write it is you would say C of, what's the x value? Which one's the x value? 0 equals 100. That's how you would write the point. C of 0 equals 100. That's the math language. Is a, would you call that an absolute max or a relative max? Is a, yeah, I guess I need to say an absolute. And the other word they could use is a global maximum. Okay, now you tell me, how do you think you would represent this point right here? How would I write this as a point? T. Not T? Oh, I see, because that's the T. You don't label it by, I need to fix this. This wouldn't be C of x. This would be called C of T, because that's a T axis, not an X axis. Okay, so you would not use the letter T. What would you do instead? Follow this model right here. C 5 is a, would you call that a absolute or a relative? Absolute. And so absolute, which again, they could use the word global as well. Global minimum. That's how you would write that. What's another name for this point? Not only is it a minimum, what else is it? If it hits the t-axis in this case. A zero. We could call this a zero. We could call that a zero as well. Okay. Additionally, label any extrema as either global or local. Okay, so this we said is a global. By the way, every type of maximum whatsoever or minimum is always a local. Everything is always a local, but it's not always global. Global just means it's the absolute highest as well. Okay, so this would be global and local minimum. A global and local. This would be a global and local. So everything's a local, not everything is a global. Just so you know. So if they ever say local, that include them all. All right. There's that type of problem. Make sure you remember extrema, how those work. All right. One more time. The graph of the function models a percentage of charge in a phone battery over a period of time. I don't know why I didn't change this. You can't have a negative charge. I don't know what's going on. How about this? On this function's domain, how many maximums would this have? How many maximums do you see?
What?
Right here, one. You talking about right here? That is a maximum, but it's not the only one. There's one more maximum somewhere. The origin point, very good. That is a maximum. It's an endpoint, that's a maximum. So let's talk about what type of maximums these are. Is this a global or local? Because I'm using their words now. Global or everything's a local, but is it also a global? This is only a local. A local means it is a max, but it's not the highest max overall. What about this one? Global, which would make it global and a local max. Okay. How many minimums do you see? Two. Very good. Two minimums. So what type of minimums are they? What about this one? If it's a global, guess what it always also will be? Okay, again, everything's always a local. It's just a matter of whether or not it's also a global. Local just means in the area, it's a minimum. In the area, this is a minimum. But global means it's the lowest overall. And this should be a letter V because that says V of t. Based on this graph, how many extrema does the function V have on its domain? We have 4 extrema. 4 extrema. Since I'm not going to plug in points in this one. Additionally, label any, so we label them. Remember how you would write the points? You would label them like I did here. That's how you would label if you had to label on the test. Okay? Questions on that topic? Ready? New topic. In Unit 1, so far we talked about different tables. And I want to make sure you understand how this works. It says complete this table if y equals f of x. So I have an x column here and y equals f of x. Now g of x, it says, is equal to f of x plus 1 minus f of x. Now, f represents what letter? X or y? What does f represent? Y. So if I take one y and subtract it by another y, what's another way of writing a y minus another y? What if I had like a y2 minus y1? What's another way we could write that? Y'all are lost. What does f represent? A y. I have a y there minus another y. So I'm doing it like y2 minus y1. Do y'all remember a formula for this? Yeah, what was the formula that starts that way? I hear slope. So if it was slope, what needs to be on the bottom? Okay, now I want you to look on the inside. Are those the exact same x's? Exact same? What's the only difference? This one. So let's plug in a number. Someone pick a number for x. Pick any number you want. What number y'all want to use? 3. If x is 3, then what's 3 plus 1? 4. You see how that's saying the x is like 4 minus 3. What would be 4 minus 3? 1. So the x's are always going to equal 1 here. They're always going to equal 1. Pick a different number. What if x wasn't 3? Pick a different, any other random number. How about 10? What if x is 10? What is 10 plus 1? 11. What's 11 minus 10? What are you always getting here?
1.
Since that's doing the dividing, do I need to write that? Do I need to keep a dividing by 1? No. So you could actually, Say that simplifies out of there. I don't need that. So this formula right there is the AROC formula. What this is right here, when you see this, this means AROC. You following me? So what is equal to AROC? The function g. I'm going to put here g of x equals AROC. You all tracking with me? So if this is concave up, if f of x is concave up, what could you tell me is true about g of x? Do y'all remember? If this is concave up, what's true of g of x? Not positive. Good try, but not positive. It's increasing. The word was increasing. If f of x is concave up, then g of x, which represents the AROC is increasing. Do y'all remember that? Now come over here. It says h of x equals g of x plus 1 minus g of x. What do you think that's representing? That's doing the change of what? That's if this was the change of y's, meaning that was, whoops, that was the same thing as delta y. That was changing the y's. This is changing the AROC. This is delta AROC. Let me put h of x. H of x equals delta AROC. Okay, if this is concave up and this one is increasing, what has to be true of this column? Positive. Very good. I'm not hearing enough voices. I don't know if you're just totally lost, if you're preparing to fail, or if you're preparing to pass. But I don't see very many notes out, and if you're not answering very many questions, I would think you'd be writing some of this down. Hint, I would be writing some of this down if you don't know it. Now, if you know it, that's one thing. But I'm not hearing much. So the rule was, if a function is concave up, what does that mean about its AROC? Increasing. Does it have to be positive? Does it have to be negative? It could be either one. It could be both. But the AROC must be increasing. And what's always true of delta AROC? Positive. All right, I'm not going to wait around here. You're going to have to catch up to me. Here you go. Next one. Same setup. Same exact setup. I want you to take a look at this. What if I told you to complete this table? And what I told you up here at the equations, I have it just written out already. If the delta AROC is negative, what could you fill in on the table? By the way, there would be nothing over here. We couldn't, this could be whatever. I'm going to put a question mark, meaning we don't know what it is. But the one thing we know is true here is it's concave up. We know this has to be increasing. We know this has to be positive. Okay, we don't know what the x's are. They could be anything. Okay, what could you tell me if this is negative? What could you tell me has to be true? What's concave down?
Y equals f of x.
The original graph, y equals f of x, the original graph is concave down 100%. That's true. Anything else you could tell me? What is decreasing?
AROC.
This is decreasing. Could you tell me anything about the x's? No, can't tell anything about those whatsoever. They could be any values. They could be positives. They could be negatives. They could be doing anything over there. There's no rule connecting those. Does it make sense? By the way, as a visual, what does concave up look like? A concave up would look like that. The graph is making a move like that. That's concave up. That's what that would look like. AROC increasing, that means the slopes. So if I took this right here and I copied it, if I took this, what it means for AROC, if you think of it like secant lines or a ruler. What this is saying is if you made little lines on it, what's happening with each of the following, I'm going to use tangent lines rather than secant lines. What's happening with each one of these tangent lines as they follow from one to the next? What can you tell me about each tangent line? The slope of each tangent line. You see how the slope is increasing as you go along it? Each slope gets a little bit bigger. Bigger means more positive, more and more positive. You see how each slope's doing that? Okay. Marcus, make sure you're not distracted on something else over there, okay? And delta AROC being positive, that just means if you took the change, if you subtracted the slopes from one another, you're getting a positive number each time, just because it's getting more and more bigger. Okay, let's go to the next one. Now that we put this together, what would concave down look like? It means the graph is doing something like this. Okay, so what does it mean if the AROC is decreasing? Would I actually be looking at the original graph? No, you would be looking at tangent lines on the original graph. What can you tell me about each one of the following tangent lines as I go from one tangent line to the next? The slope of each tangent line is decreasing. That's what that means. The delta A rock would be negative. You wouldn't have a picture for that. Okay, cool with that? All right, I'm going to the next one. What if I told you f of x was increasing? What does that mean of g of x? Do we have a rule if f of x is increasing? This could be anything. We don't know anything about this. What about delta A rock? If this is increasing, do we know anything about that? We don't know anything about this at all. Do we know anything about x's? Don't know anything about that. So this being increasing, that doesn't tell us anything except for what does it mean if the graph is increasing? Not necessarily concave up, that would be the different word. If f of x is increasing, doesn't mean positive. What it does mean is on a graph that the curve is moving a direction. Which way is the direction moving? It's moving up. Does that make sense? You know, that might make more sense of it. Let me put an F on every one of these black ones so that you can see what's what. So G would represent all those tangent lines. And G is the tangent line. Okay. So all this means is that F is going up. Could I have it concave down? Yes, this is concave down. I intentionally did. This part's concave down, but guess what about this part? That's concave up. This is concave down. This is concave up. So I showed you that if it's increasing, it doesn't mean anything about those. Following me? I'm trying to make sure you know what word belongs where. Okay, on this one, if I told you delta A rock was decreasing, I'm sorry, just A rock was decreasing. Does that mean anything to us?
That's going down.
What's going down? Does that tell us anything about the other? This has to be negative. I agree with that. This is concave down. Very good. So I'm making sure you know what word goes where. That's what this goal is. Okay, if it's concave down, what does concave down look like? Upside down parabola. This would be F. What does it mean if the A rock is decreasing? Visually. The secant lines or the tangent lines. I'm going to draw tangent lines where it just touches it once. The slope of the tangent lines are decreasing. That's what that means. The slope of the tangent lines are decreasing. That's what that means. Delta rock or A rock would mean the slope technically of secant lines, but I'm drawing them as tangent lines. The slope of those lines are decreasing. So A rock is very similar to slope. Remember how I showed you that in my ruler earlier? What's A rock similar to? Slope. I put on here slope ruler. Yeah. Okay. How about this next one? I got a bunch of these just to make sure you can practice. What if delta A rock is concave up? What does that tell us about the A rock? Nothing. Very good. You're catching on. Nothing is true. It doesn't tell us anything about that. What does it tell us if this is concave up? What does it tell us about f of x? Nothing. What does it tell us about the x values? Nothing. It doesn't tell us anything. Did I put an x question mark over there? It doesn't tell us anything if that is concave up. What's the only two words that matter for delta A rock? Positive or negative? What are the only two words that really matter here? Increasing or decreasing? What's the only words that matter here? Concave up or concave down? About making, when I'm saying that, the only words that matter about testifying to the other columns. So that doesn't tell us anything, does it? We have no idea. Okay. What about this one? If I said positive here? A rock would be increasing. What does that mean about f of x? Okay, you're catching on. What does it mean about x's? Nothing. Those x's could be whatever they want to be. So if it's concave up, the graph would look like a parabola up. And visually, what would a rock being increasing mean? What does it mean visually if the A rock is increasing? That the slope of the tangent lines, what are they doing? They're increasing. Each line, if you keep adding more and more lines, the slope of each tangent line is increasing. It's a greater and greater slope all the way around. Have I done enough of these for you to get them in? What's the only two words you're looking for in this column? Concave up or concave down. What about A-rock column? Increasing, decreasing. What about here? Positive or negative. Very good. Okay. By rule, let me go back here. Did I ever have a negative or positive in the middle column? No, I did not. What's always true? If you ever see the word negative or positive, it does mean the previous column is increasing always, but that doesn't mean much. So like if this is increasing, actually one thing I could have said is if this is increasing, we could write one thing here. I want to go back to this one. This was wrong. I should have put that this is positive. Now that doesn't mean anything for a picture though. It doesn't mean that it just means that no matter where you pick the graph, it'll be up. I should have said that. Sorry, let me go back. Anytime something, if you have an increasing word, the next column would be positive. But that doesn't tell you much on here for concavities because all it just means is that every tangent line is always pointing up. But you see how they're kind of going back and forth. The slopes are, some of them are increasing, some of them are decreasing. You see how it works like that? How some are increasing, some are not, I'm sorry, they're all just going up, but they're not, the slope is going back and forth. Sometimes the slope is greater, sometimes it's less, sometimes it's greater, sometimes it's less. So that's all that means. If you have increasing, the next one is always positive. If you have a decreasing, the next one is always negative. But truthfully, what you're looking for is you want to see concavity, followed by increasing, decreasing, followed by negative, positive. That's what you're ultimately looking for. Let me make sure I got the right end. Okay. Moving into our last topic here. Let's say we're looking at this. It says on which following, so you're expect to see a lot of these throughout the year, a ton of these, all throughout the year. This is not going away. We're going to see a lot of these. I want to make sure you understand this. On which interval is the function decreasing? Let me pause there. What does it mean if it says the function is decreasing? That the function is going a certain direction. Which way is it going?
Down.
Going down. Let's first, based off that, here's our function. We'll call it f. What parts could we scribble out? Let's see, it has to be going down. Is it going down between F and G?
Yes.
Is it going down between G and J?
Yeah.
Is it going down between J and K? Is it going down between K and P? J to K, it's not going down. K to P, it's not going down. You following me? Now, while its rate of change is increasing, so that means if you kept drawing those lines, if its rate of change is increasing, that's like the slope of the secant line, has to be moving more and more up. Which one would that be the case? Would it be the first interval that my slopes would be increasing? So I'll do this in red. Let me actually underline this in red. Slope is increasing. That means my tangent lines are becoming greater. So here we go. I'll put tangent lines on here. Does it look like so far my tangent lines are increasing or decreasing there? They're decreasing. Okay, let's pick it up from G. So from G, whoops, I kind of messed that one up. What's happening from G? I messed up both of those, didn't I? I mean, this one's hard to draw because it's like right on top. It's so flat in there. But there's that one, and let me get that one fixed. Okay, now it looks a little bit better. What's happening from G to J? What's happening to my slopes? They start really negative. Are they ending really negative? No, you see how it's turning more and more positive? So which one's the correct answer then? G to J. That would be the correct answer. Make sense on how to do that? Okay, I want to do another one so you can see it and think about it yourself. How about this? On which interval is the function increasing while its rate of change is increasing? Again, what does it mean if the function is increasing?
It's going up.
I'm going to call this F. F is going up. So what about from F to G? What do y'all think? Priscilla, wake up, please. No there? What about G to J? No, decreasing. What about from J to K? Increasing, K to P? Okay, so these two are out. Those two are the options. Its rate of change is increasing. All right, let's put those on there. Here's the tangent line, so I'm gonna start here. Are the slopes are changing. How are the slopes changing so far? Increasing. What about now? Nope. So what happened to my slopes here? They're increasing. What about from K to P? What happens to my slopes? Are they still increasing? No, you are answering it as if they're positive. I'm not asking if they're positive. I'm saying, are they still increasing? Is it becoming a greater and greater slope? No, my slope's getting less and less. It's getting closer. It gets to 0 right there. So the correct answer is J to K. Make sense on how to do those? Okay. I think I have one more here, and then I can show you a different way they could ask the same question, but different words. On which interval is the function decreasing while its rate of change is decreasing? I'm going to pause this and give you a chance all to think about it. All right, picking up. Let's start with the function decreasing. I'm going to call this function f. If f is decreasing, what does that mean about f? Not concave down. It's going down. Yeah. F is going down. That's what it's telling you. F is going down. So is f to g a possibility? What about g to j? J to k? K to p? No. These two are out. Its rate of change is decreasing. So how do we do that? How should you think of rate of change? The slopes of the tangent lines. That is a rock. We want to know the slopes of the tangent lines here. And so let me change color so it's blue. Okay, tell me about the slopes as I start here. What's happening to each slope falling right now? How's my slopes changing right now? They're decreasing, okay? What's happening on the next little interval? Okay, so does that mean it's getting bigger or smaller if it's going from a negative closer and closer to 0? Is it getting bigger or smaller? Think of an x-axis. If you're going from a really negative towards 0, are you getting bigger or smaller? Bigger. So here it is decreasing, here it is increasing. We wanted it to decrease, so the correct answer would be A. You got it. Okay, so now let me show you a different way they could ask the same question. Same question, just different words. They could say, oh, I have one more. I'm sorry. I had one more I didn't realize. Let's just go quicker here. Function increasing. Where is the function increasing? What just let's call out where is not a solution? Where is it not increasing? F to G and G to J. That's definitely decreasing. While its rate of change is decreasing, what are we looking for if the rate of change? We want slopes getting smaller and smaller and smaller. Is that J? Are my slopes there getting smaller and smaller? No, my slopes are getting taller and taller. But what about what's happening to my slopes here? Now they're getting smaller. So the answer would be K to P. Okay, here's a different way they could answer it. Ask the same question. On which interval is the function decreasing at a decreasing rate? So this is how they can condense it as the year goes on. And they will condense it to like this. Don't be confused. On which interval is the function decreasing at a decreasing rate? Let's break it down. That's two separate pieces of information. Tell me about the first part, function decreasing. What does that mean if it says the function's decreasing? Going down. Which two can we eliminate? J to K and K to P. A decreasing rate, what does that mean when it says decreasing rate? That's your slope of your tangent lines. So we want those pointing more and more down as we go along. Is it F to G? Or is it going to be G to K, G to J? F to G. That's where the slopes are decreasing. It'd be F to G. So this is the same thing. We've had an F to G. I'm going to go backwards. When we had F to G, Function's decreasing while its rate of change is decreasing. They will condense it in the future to just say this: the function is decreasing at a decreasing rate. It's still two pieces of information. Separate them and you'll get the answer. Make sense? I have, I think, two more. Do y'all want to do them both, or are you good? Do y'all want to just try them? Or no? Move on? Okay, there's two more. I'll post them online if you want to take a look and then check with me later. Okay, how about this? Let's finish up with what we did last lesson. It says, give an example of a polynomial function that could satisfy the following in behavior. Then give a counterexample of an equation that would not satisfy. All right, so what I want you to do when you get this problem is I would encourage you to translate these symbols into what way the graph should be moving. When it says x approaching infinity, which direction does that mean the graph is moving? Remember, a limit doesn't tell you where the graph is. A limit tells you where it's going. Where is it going if x is going to infinity? The graph is going to the right. And what does it mean if the f of x is going to infinity? You could say up. The mathematical term would be it's rising, but up is fine. So as the graph goes to the right, I'm going to just do a quick sketch. As the graph goes from I'll just do it from the origin to the right, it's going to rise. Be cool so far? We'll do this one in blue. This one's blue. We'll do this one in green over here. Okay, let's translate. What is it saying if x is approaching negative infinity? What does that mean? This is going left. What does this mean about f of x going to infinity? Rise. So as we go left, the graph needs to rise. What type of an equation would do that? Yeah, parabola. What's an example of a parabola? So any function that is has a leading term that is what power? Even or odd? Even. Yeah. So a good example. So anything would work is where your leading term, it'd be take two things. The leading term is positive and of even degree. What does degree mean again? Highest power. The highest power has to be an even number and positive. So I heard y equals x squared. Would that satisfy? Would it satisfy if it was y equals x squared minus 3x? Does that still work? The highest power is that. Does it still work if it's plus 7x cubed? No, that would not work. But if I did like a plus 5, would that still work? That would work. That would be good. Okay, what's an example of a bad? We'll throw out a few bad examples. What are some bad examples? Or the counter, if you will. What are things that would not work? An odd power. So x to the 7th power. That would not work. What's another one that would not work? How about negative x to the 6th? Something like that. That would not work. Why not? What would the negative do? It would flip this graph upside down. Does that make sense? You're going to need it. As long as you know those rules, you can put it together. It's positive because it's up. Does that make sense? It's a positive because it's up. It's a positive because it's up. And it's even because these are reflecting on the y-axis. Positive because it reflects this way on the y-axis. It's even. It's positive and even. Okay, how about this one? We'll just do a couple of these and we'll move on. Translate for me. Well, again, we'll do this in blue. We'll do this one in green. What direction is this saying to go? Left. What direction does this say to go? Rise. Is that right? Yeah, okay. What about over here? We'll do this part in green in a moment. What is this saying to do here? To go right. And here. Okay, the word would be fall. So if we go to put together a graph, just a quick sketch is all you need. As we go left, we rise. So from the origin, I'm going to go left and rise. As I go to the right, I fall. Okay. Tell me about the function. Is this a even or odd power? Odd degree. Odd degree. Let me put that word degree on the previous one. Even degree. Is this if it's odd, is that a positive S curve or a negative S curve if it decreases going left to right? It's negative. So this is a negative leading term. So here's some good examples. Y'all call them out. What are some good examples that would work? X to the 7. Is that good so far? Nope, it's not. Okay, what if I did minus 9x to the 9th power? Is that now good? What's my leading power? 9. Is that positive or negative? Negative. That would work. Okay, what's a bad example? There's a good example. How about here? I'll just do it like this. Y equals, this time I'll do it x to the 9th minus 9x to the 7th. Why is that now bad? It's positive. That would now no longer be good. We cool on that? On how to come up with those? All right, and I can't remember if I did one more of these or not. What does it mean for a function to be an even function? What does it mean if a function is even? Okay, it's more than a parabola. It's got to be more specific. Not just the degree. What does it mean for the function to be an even function? It's telling you more than just the degree.
It's like the y-axis.
Okay, it's symmetric with the y-axis. That's true. So you can put that in there. The y-axis. The y-axis. Let me say it's symmetric with the y-axis. Let me put it that way. Symmetric with respect to the y-axis. That's a true statement. What does it mean when you look at the equation if something is even? Something to do with the powers. Do you remember the function? It's more than the degree. Degree just means the highest power. Nope. It's that all powers are even. All powers are even. And mathematically, the symbol was this. Here's the mathematical language. Okay, what did this mean? When you see it this way, this is telling you for the function f that any negative x value produces the same y value as the positive x. Opposite x's produce the same exact y. Do y'all remember that? Opposite x's produce the exact same y. F represents the y. Since both f's are positive here, the opposite x's produce the same exact y value. That's when if they gave you a table, that's what makes something even. What makes something even? I'm just going to write that in. I'm going to make sure you got that. This is opposite x's. Opposite x values produce the same exact y value. Opposite x values produce the same exact y value. For example, what are two numbers that could be opposite x values? Two and -2. They would need to produce the exact same y value. 5. 2 and -2 need to both produce a 5 or something like that. Okay. What does it mean for a function to be odd? If it's odd, where is the symmetry? It's not with the y-axis. Do you remember what the symmetry is with? Nope, not x-axis. I'll give you a hint. It's diagonal. So what do you cross over if you always go diagonal? The origin. Symmetric with respect to the origin. All powers, if it's odd function, all powers are odd. The formula was this: f of negative x equals, put a negative in there, negative f of x. That means opposite x's, you see how the x's are opposites? Produce, look at the f's. Are they the same f or opposite f's now?
Opposite.
Opposite x's produce opposite y values. Opposite x values produce opposite y values. Okay, what would it mean if a function is neither even nor odd? Well, what would it mean about symmetry if it's neither even nor odd?
It's not symmetric.
It's not symmetric. No, it's not symmetric. Good. What would it mean about the powers if it's neither even nor odd? They're even and odd. Powers are even and odd. Mathematically, this would not be true, nor the other one true. So I'll put a line through it in a second. Let me copy and paste this in. That would mean these are not true. I don't know if I have a does not equal symbol. I'm gonna look real quick. If I do, it'll be cleaner than me just putting a line through it. But I might just have to put a line through it. I'm not sure if I have that symbol on this program here. This program is not quite as good. Math symbols. Look for it does not equal. Do y'all see one? I didn't see what there. How about favorites? I might have favorited it if I have one. No. Okay, math symbols. One more time. Let me just scan real quick for it does not equal. Here's a bunch of where above there.
Like, four down.
Go down.
Go down.
Oh, right here. Add to favorites, so I don't have to do this next time. Great. And I'll just copy and paste here. What is this saying? It's saying opposite values produce random, I'm just gonna say random y values. They're not the same, they're not opposites, they're just random x values. Does that make sense? So opposite x's do not produce the same y, opposite x's do not produce opposite y's. Opposite x values produce just random y values. That's what it means to be neither even or odd. And so an example, it says, what's an example? X cubed plus x squared. That's an example like that. I think that might be the review. I think that's it. I don't remember putting anything else on there. Let's check it. Oh, one more. What does it mean to be a conjugate pair? What does conjugate pair mean? Do y'all remember that? You have a negative and a positive. What have negative and positive? Negative and positive pairs. Factors or zeros, whatever we're looking at. Can you give me the two different examples of factors that are conjugate pairs? What are the two types of number sets that are always conjugate pairs? Do you remember? What always comes as a conjugate pair? Imaginary is one. Imaginary and irrational. Imaginary and irrational. So if you wanted examples, if they gave me an x plus 2i, guess what I also have to have? X minus 2i. If I'm finding a 0 and I find that x minus the square root of 7, irrational means never ending, never repeating decimals. It mostly is pi, the letter e, and square root symbols. So I did a square root. If you have x minus square root of 7, guess what we'll also have? X plus the square root of 7. Like that. That's a conjugate pair. Okay? So those will always be conjugate pairs. Now that's it. So what I want you to do, if you go to Delta Math, you have a review, you can pick up that and start working. Hopefully you saw some stuff that maybe you had forgotten, but now you remember. We'll have our test on Friday.